Hey, Algebra 2, it's Mr. Szybisty, and in Unit C3, we're going to talk about something called an imaginary number. Up to this point in your math career, you've only experienced real numbers. Numbers like 3, and 10, and -2, and 3.14, and all these different numbers that have come up. And every single one of them could be put on a number line. 0, 1, 2, 3. We could find some place for them. But now you have gotten old enough where we can start talking about numbers that can't be put on this number line. In particular, what happens if you wanted to take the square root of a negative number? I know that the square root of 1 is 1 and it would go right there, but what about the square root of -1? This is something that mathematicians have talked about for a very long time. And eventually, about 500 years ago or so, they decided that they were going to call this number, the square root of -1, they would call it I. And that I would stand for an imaginary number. This would allow us to talk about all different sorts of square roots of negative numbers. Like the square root of -4, we could now call it 2i. Or the square root of -25, we could call it 5i. So Unit C3 talks about the imaginary number I and how it works in the relationship with everything else. Let's get started. We start with trying to simplify the square root of -48. And we're going to do it just like we did in C2. So if you haven't seen Unit C2 yet on how to simplify radicals, go back and rewatch that. But if we're taking the square root of a negative number, we think back to the way that we defined this. That if you want to take a square root of a negative number, that's really an imaginary number I times the square root of 48. Now we can simplify the square root of 48. So we're going to write 48 on the outside over here, and we're going to turn this into a factor tree. Well, I know 48 is 6 times 8, and 6 is 3 and 2, and 8 is 2 and 4, and 4 is 2 and 2. And now we can look for groups of two numbers that are the exact same, and we can pull them outside. Well, here's a group of two numbers that are the same. There's two 2's. So I'm allowed to pull one 2 outside. Here's another one. I'm allowed to pull another 2 to the outside. And remember, we're always multiplying. The 3 is all by itself, so that's going to go inside the square root. The last thing that we can't forget is this I that was right here. So that goes there. 2 times 2 is 4. 4i root 3 is our completely simplified version. Let's see another example. Square root of -32. The first thing I notice is that we're taking the square root of a negative number. That means it's going to be imaginary. And I can write it like that. And now it's time to break up the square root of 32. So I know that 32 is 16 times 2. 16 is 4 and 4. 4 is 2 and 2. And this 4 is 2 and 2. And now I look for groups of 2. Well, here's a group of 2. Two 2's, which means one of those 2's can go to the outside. Here's another group of 2. So those 2 can go to the outside. Remember, we're multiplying all the numbers that are either on the outside or they're left over. There's one 2 left over here, so that goes inside the square root. And then we can't forget about the I. 2 times 2 is 4i root 2. And there's our completely simplified answer. Let's see another one. Here we have a U try. Simplify the square root of -50. Pause the video, try to do it like we just did, put it in your notebook, and then we'll talk about the right answer. Pause the video. So here's the answer, 5i root 2. Check your work if you didn't get it right. Make sure you write down any questions that you have about it so we can talk more in class on the next day. Now here's a very important note. Usually when there is a square root, that will go at the end. And we'll typically put i's at the end of our expression as well. You'll see that later on. But when we have them both, we're going to put the I second to last and then the square root last. That way it avoids any confusion that there might be about what's supposed to be inside the square root. So write this in your notebook. When you are writing an I and a square root, we write the I first and then the square root. Now let's take a look at multiplication. Alright, in this problem we want to multiply two complex numbers here. A complex number is a number that has a real number and an imaginary part. So I'm going to multiply these two complex numbers together. 3 plus 2i times 4 plus I. So what I'm going to do is make a box just like we've done before with our multiplication. On one side I'll write 3 and 2i and make it so that they have their own row. On the top here, 4 and I. Make it so that they have their own row. Or in this case, column. Now, 3 times 4 is 12. 3 times I is 3i. 2i times 4 is 8i. And in the lower right hand, we have 2i times I, which is 2i squared. Now, before we move on, I need to talk to you a little bit about I squared. So what is I squared? In Algebra 2, when we deal with an I that's raised to an exponent, we don't like it. If we are dealing with I squared or something like I to the 50th, we're not going to settle with that for our answer because there's a way that we can express it in a simpler form. Now, I to the 50th is a little extreme, and we're going to talk about in class an easy way to figure out what this is equal to. But right now in the video, I want to deal with I squared. And what does that mean, and how can we simplify that? Well, if we go back to our initial definition of what is I is the square root of -1. So I'm taking the square root of -1 squared. And when you're dealing with a square root and a squared, they're going to cancel each other out. They're two operations that undo each other. They're inverses. And so these will disappear. They sort of kill each other. And all it leaves is -1. So we're going to write as a definition that I squared is equal to -1. Let's get back to our multiplication problem that we were doing before. So in the lower right hand corner, 2 times I squared, if we know that I squared is really -1, this is 2 times -1. We're going to write this as -2. So now I can write everything out. 12 plus 3i plus 8i plus -2. And I can combine like terms. 12 and -2 is 10. And 3i plus 8i is 11i. That I acts just like a variable. It acts just like x. And this is going to be our final answer, 10 plus 11i. And notice with the I, we're going to put it at the end. When we write a complex number, remember it's a number that has a real part and an imaginary part, the real part will come first, the imaginary part will come second. Let's see one more multiplication problem today. So here we're going to multiply two complex numbers, 1 plus 2i times 2 plus 3i. So I'm going to make my box like I've done before. 1, 2i going to go on the side, 2 and 3i will go on the top. So now it's time to go through and do the multiplication. 2 times 1 is 2. 3i times 1 is 3i. 2 times 2i is 4i. And 2i times 3i is 6i squared. Just like before, I remember that I squared is really a -1. So this is 6 times -1, which is going to be -6. Now I write everything out like I did in the last example. 2 plus 3i plus 4i minus 6. And now I add like terms. 2 and -6 is -4. 3i and 4i makes 7i. And there's my final answer. Make sure you write your summary. Write down the 2 questions that you've got or any questions that you have so we can answer them in class. Can't wait to talk in class about some more stuff about complex and imaginary numbers, and then we'll continue to work on solving quadratics. Everybody have a good night.